Greetings to all of you. This is a session where we are going to discuss about intermediate chemistry. Will be helpful for your international entrance or any competitive exam you are preparing for. India level JEE Advanced, JEE Mains. This is for what? IIT and NIT entrance examination, that is the technical domain. NEET chemistry for medical entrance all across India. Telangana and Andhra Pradesh MCET examination for engineering stream, again it is the technical domain. In addition, you're serious about any government examinations, any career opportunities from the government organizations where you have to attempt competitive examinations. In that, general studies question paper will be common for all. In general science, there will be a content of what we are discussing, chemistry will be appeared. Let's enter into our today's session. Explain the geometrical isomerism of following compounds as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Here we have to assign geometrical and in specific E and Z nomenclature to be assigned for two compounds with a double bond. Here is ethyl, chloro, bromo, hydrogen are the functional groups which are denoted with four different colored boxes. Here also you can find these four colored boxes indicating four different functional groups. Especially EZ nomenclature is applicable to the double bonded compounds which occupied by four different functional groups in their vicinity. Fine. Let me go with how to assign E and Z. E for entacogene, where two higher priority groups are oppositely inclined. Z for Jusamen if two higher priority groups are same side aligned, right? So this is purely applicable to alkene type of compounds where the compulsory necessity is double bond. Around the double bond, if you observe, higher atomic number will get higher priority in accordance with the Carnegie-Prelog rules. So if you observe here, carbon directly linked with chloro, carbon directly linked with carbon. So that obviously higher atomic number chlorine will retain one priority and this ethyl will get second priority. Move on to second carbon. It is located with one side bromo, one side hydrogen. Obviously, bromo atomic number will be higher, so that number 1 will be accorded and hydrogen will be assigned with number 2. This is the way we have to give the individual numbering for two carbons which are connected with the double bond. After giving individual priority to both the carbon atoms, we have to check whether 1-1 on the same side or 1-1 on the opposite side. If you observe, around the double bond, one is upside, one is downside. This means the two similar priority groups are in anti-configuration, which are opposite to each other. Whenever opposite, we can say trans. That trans geometry is called E. E for entacogene. So that E is the geometrical isomerism for the compound, and where you have to go for IUPAC nomenclature, we can count the number of carbons 1, 2, 3, 4 carbon length chain it will be. So that but will be the parent chain, and wherever carbon of first carbon is accomplished with the bromo, so that let me mention one bromo. On second carbon I have chloro and one butene is the complete name. E, one bromo, two chloro, one butene is the name. If you go with second one, again 1-1 priority groups are in opposite direction. Whenever opposite direction, let me mention E. And on the first carbon, see, chloro is there, but need not to mention one chloro first. Rather, we have to go for two bromo only, because whenever we are writing the IUPAC nomenclature, we have to follow the alphabetical order, so that bromo will come first, later chloro will be mentioned. Though bromo is there in the second carbon, we have to mention two bromo, one chloro, one butene as the name of the compound. These two are not similar, both are different compounds, but both are having a similar geometrical nomenclature. E configuration is assigned for both. This is the way IUPAC nomenclature is given. For question number 1, here both the isomers in accordance with the EZ nomenclature will be E isomers only. right? Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. A gaseous substance is slowly cooled. Temperature recorded every second. The results are shown on the graph. This is about the results in accordance with the time and temperature. Fine. There is a kind of ups and downs over there. And if you observe the entire one, the thing we need to predict, we need to anticipate will be at which point is the substance a solid in nature, solid substance to be identified in order to get that one. So let me check. Let me mention the solid is available at this point, so the tick mark will be oriented. Why we are making tick over there? Let's get the detailed explanation. Increasing temperature on y coordinate. If you observe, y coordinate is mentioned for temperature. So an arrow is mentioned towards upside. That indicates what temperature is gradually increasing. If you go for higher temperature, for example, I'm taking the point here. Higher temperature, this is an elevated temperature. Obviously, any substance at elevated temperature exists in gaseous form, so that we are taking a gaseous substance. We started at this temperature and the substance exists in a gaseous compound where time 0, on 0 coordinate of the time we are observing there. So at a time 0 and elevated temperature, there is a gas initially. Initial substance is gaseous in nature, already they mentioned. And let me say this is the elevated temperature and the time taken 0. That means at that instant only we are thinking. As time passes, there is a gradual decline in the temperature as we are moving. So half an hour, 1 hour, 1.5 hours, 2 hours like this. Let me say this is the time gradually increasing, temperature gradually decreasing, so that you can observe the curvature towards lowering the temperature. This is the way decline in the temperature we can notice. As temperature lowers, initially gas get compressed into liquid. Liquid still converted into a solidified form by the compact packing, right? So favorable requirement for the liquefaction and subsequently solidification is possible. At this point D, we can clearly mention entire molecules got cooled and sufficient spacing is occurred in between and regular arrangement that gives rise to the solid in nature. So that we can say at this point, at this final point, you can say lower the temperature, higher the time period of duration, and the solid is the substance what we are taking initially, right? So this is the way we can answer the question. At this point, you can notice the solid substance over there. For question number 2, beyond the point D, we can notice the solid substance. Beyond the point D onwards solidification started. Beyond the point D also solid is completely existing. So that we can say beyond the point D, there is the existence of solid substance is possible. Fine. Move on to question number 3. Let me move to question number 3. Question number 3 is collected from JEE Advanced 2019 question paper, and paper 1 is taken into the consideration. This is the question. Each of the following options contains a set of 4 molecules. Identify the options where all 4 molecules possess permanent dipole moment at room temperature, right? So the question is, though we are having these many components, we have to identify the molecules which are containing permanent dipole moment at room temperature. The molecules with permanent dipole moment to be depicted. Okay. निम्न विकल्पों से 4 अणुओं के समुच्चय हर विकल्प में दिए जाए हैं. So each option is having 4 molecules. सामान्य ताप पर जिस विकल्प और विकल्पों के सभी 4 अणुओं की स्थायी विद्युत आघूर्ण परमानेंट डाइपोल मूवमेंट है, उसे चुनिए. So उन्हें चुनिए. You say means a single one, or else more than one option may possible, so that उन्हें चुनिए. Fine. So among four options, the molecules which are having permanent dipole are mentioned with option number 1 and option number 4 as well. Let's see in detail what is meant by dipole moment. The concept is collected from Liber text chemistry. Dipole moment occurs when there is a separation of charge. Dipole stands for two poles. Two poles means what? One positive end, one negative end. One positive pole, one negative pole will be there, right? So if any bond made up of covalent, so one of the molecule of higher electronegativity and another of lower electronegativity, so that there is a charge separation we can notice. The charge separation gives rise to dipole moment. The compulsory condition in order to calculate the dipole moment is molecule must be non-symmetric. Symmetric molecule gives zero dipole moment. Non-symmetric molecule gives a positive dipole moment. And moreover, a covalent molecule must be polar in nature. A pole separation will be there. Two opposite charges can be separated. Then only it is possible to separate the charges. It is possible to exhibit dipole moment. If you go for carbon dioxide is a linear molecule. Have extend the charge separation between carbon and oxygen, that extend with another carbon and oxygen, so that the molecule is highly symmetrical. You can clearly see, being it is a linear, the extent of dipole by one direction exactly cancelled out by another direction, so that net dipole moment will become zero. No net dipole moment. The carbon dioxide dipole moment will become zero. If dipole moment is zero, IR signals will not be appeared. In order to get the IR spectroscopy, molecule must contains a permanent dipole moment, so that carbon dioxide will not give any spectral line in a IR spectroscopy. And if you go with water, it is a bent molecule, certain extent of dipole moment existed, and we can't compensate the extent of bonding between hydrogen and oxygen with hydrogen and oxygen, because molecular dipole is also there. So that this is regarded as a bond dipole, this is another bond dipole, and this is said to be a molecular dipole. So that being it is non-symmetric in nature, we can say net dipole is possible. Above and below the plane, you can notice the lone pair of electrons as well, which make the molecule non-symmetrical, so that it will exhibit dipole moment. This is the way we can clearly observe. And here NO2 is the nitrogen dioxide molecule. Here you can clearly observe non-symmetrical, so the dipole moment is possible. Ammonia, it is a pyramidal in shape. Nitrogen is sp3 hybridized actually, but one of the tetrahedral corner got occupied by the lone pair of electrons. That's the reason why three sides hydrogens, one side lone pair. There is a asymmetry, so that the molecule is non-symmetric, so it is dipole active. Dipole moment exhibited. When we go with POCl3, phosphoryl chloride, it is pronounced as phosphoryl chloride. Phosphoryl chloride, one side we have double bonded oxygen, in either side we have three chlorine atoms at three corners, but it is not symmetrical. We can't bisect the molecule exactly two equal halves, so that it is a dipole active. Dipole moment exhibited by POCl3, phosphoryl chloride. Move on to another compound, CH3Cl. It is called methyl chloride. Methyl chloride, three atoms are hydrogens, but one of the atom is a hetero. That means other than hydrogen, so that it is a chloro. When you see, there is no symmetry. Three sides you can see hydrogens, but one side chloro is there, so that it is dipole active, non-symmetrical. If you go with sulfur dioxide is a bent molecule with a double bond O inclination, and we can't say it is a symmetric, and one lone pair existed on the sulfur, so that it is dipole active. If you go with chlorobenzene, all the carbons of these corners are occupied by the hydrogens, but one of the carbon is accompanied by the chloro, so that we can say it is dipole active. Then dihydrogen selenium exactly similar to water, right? Instead of oxygen, I am taking selenium. So that selenium is having 2 lone pairs and 2 hydrogens, and it is a bent geometry. No symmetry in the molecule, so that again it is a dipole active. A clear description is provided. Nitrogen dioxide molecular dipole is existed, and these are called bonding dipoles. And if you see ammonia, being it is a pyramidal in geometry, all bonding dipoles are mentioned and molecular dipole towards the lone pair of electrons. So that non-symmetry is occurred, so it is dipole in nature. If you go with POCl3, so these are called bond dipoles, and there is the existence of molecular dipole. Whenever methyl chloride was taken into the consideration, a charge separation is very clear. Negative pole is occurred on chloro, and positive pole you can clearly mention on carbon, so that there is a charge separation. So nitrogen dioxide is also mentioned with the molecular and bonding dipoles like this. Fine. Sulfur dioxide is given like this. This is a molecular dipole, and these are bonding dipoles. You can clearly see dipole moment is mentioned with the mu, which are measured in debye units and also centimeters. Here is the chlorobenzene. Chlorobenzene is also clearly given with the positive charge for all the carbons, and chlorine is assigned with the negative charge, so the charge separation is mentioned. Dihydrogen selenium is molecular geometry is also clearly given, where you can see bent molecular geometry, which gives a dipole moment. And this is said to be bromine pentafluoride. Bromine pentafluoride, 4 bonds on the equatorial position. One of the fluorine is an axial, and here another lone pair is also inclined. If you see no symmetry in that molecule, so that it is dipole active. These many examples are there. All are mentioned in option 1 and option 4. So that for given question number 3, option 1 is correct. Option 4 is correct as well. All these molecules are exhibiting permanent dipole. Dipole is the indication of molecular polarity. Being it is a polar molecule, that should be non-symmetric, then only permanent dipole is exhibited. Nitrogen dioxide, ammonia, phosphoryl chloride, chloromethane, sulfur dioxide, chlorobenzene, dihydrogen selenium, bromine pentafluoride. These many molecules are exhibiting dipole moment. For question number 3, 1 and 4 are the correct answers. Move on to question number 4. Question number 4 is collected from JEE Advanced 2019 question paper, paper 1. Which of the following statement is correct regarding root mean square velocity, average translational kinetic energy of the molecule in a gas at equilibrium? Root mean square velocity is given by URMS, and average translational kinetic energy is given by epsilon average, right? So URMS is inversely proportional to the square root of molar mass. Correct or not? We have to check it out. E average doubled when its temperature is increased 4 times. We have to check out. URMS doubled when temperature increased by 4 times. E average at the given temperature does not depends upon molecular mass. Among all these options, 1, 3 and 4 are the correct answers. Okay, 1, 3, 4 are correct answers. Let me check how it is possible. Root mean square velocity definition. A square root of mean squares of the velocity of individual gaseous molecules. Whenever individual gaseous molecules taken into the consideration, square root will be taken for them, and velocity of individual gaseous molecules square root can be taken. That is called root mean square velocity, which is given by the mathematical formula. Your mass is equal to under root 3 RT by M. R denotes gaseous constant. T is the temperature on the Kelvin scale. M denotes the molar mass of the gas. It is the molar mass, right? So translational kinetic energy, the formula is given by E is equal to 3 by 2 kT. 3 by 2 kT is the formula. E average, the formula will be 3 by 2 kT or RT, where we can take the constant. URMS is given by under root 3 RT by M. So from this formula, it is obvious that URMS is directly proportional to 1 by under root m. This is nothing but URMS is inversely proportional to square root of molar mass. So inversely proportional to square root of molar mass. That is perfectly correct. In the option number 1, what they are saying is exactly correct. According to URMS is inversely proportional to square root of molar mass. This is correct only. Move on to option number 2. E average is doubled when temperature increased 4 times. So here E average directly proportional to temperature. There is no square root, nothing else. So that we can't say the relation in the second option. E average when doubled temperature 4 times is a wrong statement what they mentioned. URMS is doubled when temperature increased by 4 times. It is correct only because URMS is related with the temperature through the square root. In order to make URMS double, temperature must be increased by 4 times because there is a square root, right? So to make the equality among them, so in order to remove the square root, we can put a t square. If you are making URMS square, t will become temperature to the power 4. This is the way. Whatever they are saying in the third option will be correct. In order to make URMS double, temperature increased by 4 times is the correct one only. E average is given by temperature, does not depends upon its molar mass. If you observe the formula, E average translational kinetic energy formula is given by 3 by 2 kT, right? So 3 by 2 is the numeral, K is the proportionality constant, T is the temperature. Can you find any molar mass relation over there? So it is not dependent on the molar mass. It doesn't depends upon the molar mass, E average. That is also correct. So that we can say 1 is correct, 3 is correct, 4 is also correct. For question number 4, 1, 3 and 4 are the correct options. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. The IUPAC nomenclature of the following heterocyclic compound. This is the 5-membered heterocyclic with nitrogen heteroatom and containing N-oxide form. N-oxide, if present, what happens? Nitrogen is losing lone pair and here oxygen is gaining electrons, so that N positive and O minus is mentioned. This is partially reduced form of heterocyclic compound. There are so many options. The required probable answer is 4.4 diethyl del square pyrrolene N-oxide is the correct answer. Let me give the proper justification why this answer is the correct one. So let me show numbering of this compound. If you go with the numbering in this direction, on third carbon you can find diethyl. But I am going to make the numbering from left hand side like this. Always wherever heteroatom is there, there we have to start numbering, so that nitrogen will be assigned with number 1, carbon with number 2, and this carbon number 3, this carbon will become number 4. Wherever 2 ethyl are there, that will become number 4. Why we are moving in this direction? Because here is the double bond, so that the giving nomenclature is given in a left hand side direction only. 5-membered ring it is, right? Where 2 ethyl are present, 4, 4 diethyl are located, right? So here double bond is located in between 2 carbon atoms, del square is mentioned over there, and it is given with pyrrolene. So here there is a kind of nomenclature, we can say pyrrole, pyrrolene, pyrrolidine, right? Pyrrole means 5-membered ring containing 2 double bonds in that. That is called pyrrole, completely unsaturated. Pyrrolene is nothing but if it is partially saturated, that means only 1 double bond is there in the 5-membered ring, one of the double bond got reduced, which is called pyrrolene. Pyrrolidine is nothing but the cyclic 5-membered ring completely, this double bond is also removed. We have to mention pyrrolidine, completely saturated, 100% reduced. Okay, so why we are saying pyrrolene? Because one of the double bonds still exists. So that let me say pyrrolene. So if another double bond is also there, that is called pyrrole. If this double bond is also removed, that is called pyrrolidine. But it is pyrrolene because one double bond is there. And we are having oxygen and the nitrogen, right? Let me say N oxide. Let me repeat the name. 4,4 dimethyl del square pyrrolene N oxide. This is the right naming as per the IUPAC protocol given to the 5-membered heterocyclic. For question number 5, option number 4 will be the correct answer. Move on to question number 6. Question number 6 is collected from Gurukulam Telangana Gurukulam Degree College Lecturer Entrance Examination. Heterocyclic compound was taken, that is called indole. Now it's subjected to reduction in the presence of metal lithium, and liquid ammonia solvent was taken. Sorry, liquid ammonia catalyst was taken. Ethanol is the solvent over there. Indole treated with lithium dissolved in liquid ammonia. Ethanol is the solvent media. And what is the expected product we need to assign? Here, the important thing we need to distinguish what reagent is added, what kind of reduction is possible. There are two possibilities for the reduction. One is 5-membered nitrogen containing ring. One is 6-membered benzene ring, which will be reduced. In order to make that distinction, let me give the clear vision of reduction. If you go with palladium, reduction with palladium hydrogen, it is selective for 5-membered ring reduction. So if you see indole, this is the indole what we are taking. Palladium hydrogen reduction is specific for 5-membered ring reduction and benzene ring retained. Further, if you are making excessive addition of palladium hydrogen, all the two rings got completely reduced. Complete reduction is possible, that is under excessive quantity. If same indole is treated with zinc in the presence of HCl, only heterocyclic ring will be reduced, benzene ring will be retained. This is another possibility. But the question is, indole subjected to reduction with lithium in the presence of liquid ammonia under ethanol solvent media, the specific reduction is carried at 1,4 position of benzene ring, so that this is a kind of double bond is there. 1,4 positions got reduced. After that, still you are adding one more molecule of lithium liquid ammonia. The entire benzene ring got reduced. Double bond in the nitrogen, that means 5-membered ring retained. So that the kind of thing is available in the option number 1. So for question number 6, option number 1 is the correct answer. This is a kind called Birch reduction. Birch reduction is also called as 1,4 reduction, and it is proceeded with the electrons released from the metal, and the blue coloration is appeared in the liquid ammonia, that is due to the free electrons liberated by the lithium metal. The liberated electrons will initiate free radical mechanism over there, so that the kind of products are experienced over there will be, this is the kind of material where 5-membered ring head aromaticity is retained over there, and still excessive quantity gives rise to the complete saturation of 6-membered ring, right? So by this we entirely completed the session, and we have gone through the various dimensions of chemistry where we discussed about dipole moment and physical properties of the molecules, chemical nature of the compounds, is the nomenclature, stereochemistry part is also covered over there, and gone with the reaction mechanism in the organic chemistry, chemical reactivity of organic compounds mentioned over there. IUPAC nomenclature of the compounds also discussed in a detailed manner. Hope the session is really informative, and the kind of things what we are discussed from various dimensions of chemistry will make you enthusiastic towards learning of chemistry. And I'm sincerely request to like the channel, comment which is the important part for you for your real preparation, and share with the aspirants who are serious about the preparation. Subscribe the channel in order to receive more updates. Thank you very much for your patient listening. Thank you one and all.